So we discussed basics of databases already, and now what we are going to do is we have a sample database, right? Which I have uploaded on this link, this GitHub link. You can go to my GitHub account and search for sample files DB for SQL, and you'll find a films database, films.sql. It's a nice fun database to play with, right? It has got a lot of data, right? You can see pretty arranged form, and we talked about the fact that things are arranged in the form of tables and everything. So it will be really nice for us to actually visualize stuff if we have a sample database going along with us, right? So what you can actually do is there is a download button here. You can download the raw file. I already have it downloaded. Once done, and you have and if let's say you have successfully installed MySQL on your machine, uh, it should directly come with a MySQL Workbench. If not, then you can separately install a MySQL Workbench as well. Now, all you have to do is already if MySQL is running properly on your machine and MySQL Workbench is already there, you can open MySQL Workbench. And in MySQL connections, you will see something like a local instance 3306. Now, what is this local instance 3306? Now, try to understand it like this. When you install MySQL, it's not running and everything, right? But let's say when MySQL is running on the background, technically MySQL boots up its own server as well, right? And that server can actually get connected again through a TCP connection. So on your machine, you are already on your own machine. And from your own machine, you want to connect to a MySQL server running on your own machine. So you will do localhost and then you want a port. So default port for MySQL is 3306. You can change it, you can reconfigure it, but the default port is 3306. That's why if you will see, it says local instance 3306. That means on localhost 3306, it will try to connect to your MySQL server. If MySQL server is up and running, double clicking here will try to open an editor in front of you, and you can see an editor has been opened in front of us, right? I'll close everything so that you see everything raw and clean. Okay, cool. Now what you will do is, what you will see is like it's a pretty big, I would say, interface. A lot of things you might be able to see. If you don't want to code here, you can directly code on your terminal as well, but maybe for starters I would recommend you to try it here. It's generally a nice interface to go for. On the left side, you can see there is something called as a schema, right? You can see there is an option of schemas. Here you will find all the list of your databases. So how RDBMS works, or SQL databases work, is that in one database there are multiple tables. For example, if you make an Excel sheet, in one Excel sheet you can have multiple I would say parallel sheets. For example, if I open a Google sheet in front of you, right? If I open a Google sheet in front of you, you can see, let's say this is one Google sheet. Now inside this one Google sheet, this is sheet 1. I can add more sheets, sheet 2, sheet 3, sheet 4, and so on, right? So similar concept exists with databases in SQL as well, that in one database there might be many tables. For example, let's say if you see this flights database and you go to the option of tables, you expand tables, you can see there is a table of airplanes, airports, bookings, cities, flights, roles. A lot of tables are actually there, right? So you can keep that particular thing in mind. Okay, now you will see uh, there is already a query and some query number must be written here, kind of like an interface where you can actually write some code, right? It's a editable interface that you can write. And to make sure that you write correct code, MySQL Workbench will also show you some cool recommendations. If you want to, you can see save files and everything. If you want to open a file, you can open it from here. If you want to save a file, you can click this floppy button to save the file. If you want to run a MySQL query, then you can actually click on this thunder button to actually execute the code. For getting started, this much is something that you need to know. Okay, now how SQL actually works is that you actually try to provide kind of like a query. Okay, you try to provide kind of like a query, and in that query you actually tell what data you want, or what data you want to insert, or what data you want to actually update or something. So that's why, so in programming world also there are two types of programming languages. One is called as an imperative programming language, one is called a declarative programming language. What happens with the imperative programming language? So imperative programming language, let's say JavaScript, or let's say Python. In this imperative programming language, to do a task you have to tell how to do a task, right? If let's say you want to convert an Excel sheet to a PDF, let's say this is your task. So you have to write the code that first of all load the Excel sheet, then maybe you'll be using some library that will be parsing the Excel sheet, converting an image representation for that in form of PDF, and something it must be doing. So you have to actually step by step tell in imperative programming that whatever you want to achieve, how to achieve it. Whereas the other type of programming language, that is SQL also. SQL is the other type of programming language. So the other type is called as declarative. Declarative programming, and SQL is one of the biggest example of declarative programming language. In a declarative programming language, what happens is that instead of telling how to do something, you tell what to do. For example, you want to fetch the data from the tables. You do not tell how to fetch the data from the tables. You just tell what data you want from the table. That's it. You will just tell what, and the how will be automatically figured out by the language, because language has already configured everything corresponding to that. Let's say you want to delete some data from a table. So you do not tell that, okay, first go to this table, then search for this record, then delete this record, have some checks and everything. No, right? You just tell that, okay, delete this record from this table, and how to do it, it will automatically figure out. So in declarative programming, you do not tell how to do something, you will just tell what to do, and how is automatically figured out. That's why generally the SQL statements that you write is called as SQL queries, that you query for something, that like whatever you want, you query for that, and then in the response you get the output. How it is doing internally, you don't need to care about, because SQL has already configured that, right? That is something that you have to keep in mind. Now you can say that now we need to load the database. So you can see this is a database, right? Inside a database there are multiple tables. So you can see some syntax you might be able to see: create table, then insert into, some syntax you must be able to see. We'll come to that syntax, but let's first of all load our database. So what I'm going to do is, if you will see the all the option file, edit, view, query, there must be option of database, right? So in order to import the data, what you can actually do is, you can click on file, and you can actually click on, let's say, or you can click on here, open, right? There is a open button. This is the open button, and you can open the film.sql file, right? uh, and you can see the whole SQL file has been imported, right? The whole SQL file has been imported. Now what you're going to do is, now in generally in MySQL Workbench, what happens is, if you select a particular line and then run that line, only that line actually runs. So what you can actually do is, you can do select all. You can do Control A, Command A, select everything, and then click on this thunder button. I'll expand this menu here. Let's click on this thunder button, right? And you can see it did a lot of things. It did a lot of things. Some logs like this will come up. Some logs like this will actually come up for you as well, right? So let me actually show you, and you can see there will be a new database named as LCO films that will be created for you. So you can see, if I refresh, you can see there is an LCO films database that actually came up, right? If there is already a database with the same name in your system, then it will automatically delete it. You can see drop database. Don't worry if you don't get the syntax. All you have to do is, let me show you the step again. All you have to do is just clear everything, right? Click on this open button, click on this films.sql. Okay. Sorry. Oh, my bad. Let's close this. Okay. So now again, let's do it again. So when you see a query tab here, or you can actually do new query tab. Okay. Click here, open films.sql. It will hold the whole, make the whole SQL file. Select all, press the thunder button. It will execute everything. And if you refresh from here, you will find a LCO films database. If that, just to check how, if the database has properly imported or not, you can click on this arrow button here, so that the drop down comes, and then tables will be having a drop down. If tables are showing all the relevant tables that were there, then you can say that things are good for you, right? So this is how you can actually import the data for you, so that we can actually play with this data. Now you can actually close everything, and now we can actually very easily play with this data. Just to show you a demo, if you, so you can say that there are multiple tables. One of the tables is a actor table. So I can do something like select star from actor. Oh, my bad. What happened? Okay. Select star from actor. I'll select it and click the run button. Okay. Oh, and one more thing that I have to do. Before that, we'll say use LCO films. Okay. What's the name? LCO films. Yeah. Without the quotes, you have to write. Select all and run it. And you can see if it will successfully run, then what will happen? You will see a lot of data coming up here. Right? There is a lot of actor data that you will actually see coming up here. Right? So that's how you actually can import the data inside MySQL. Now let's say we want to see some details or see some data from a table. So first thing that you will do is you will say use LCO films, right? And let's say we say show tables. If you don't select anything and you execute, like do not select anything, right? Have your normal cursor here and just execute the whole file. Then you can see all the queries inside the file will execute, right? Use and show both executed. You can see these are the tables. Let's say I want to see details of the actors. What all actors do we have? What all actors do we have? How can we do that? So you can say to print, or let's say to get the rows of a particular table, right? To get the rows of a particular table, we use select command. Okay. So what do you write? You say select star from, and then you can say, let's say actors, actor, right? Actor is the table. So what's happening here? This select command is kind of like the read command or get command or print command. So in the world of SQL, you say read, select, read, get. Instead of read and get, you say select. So select means you are going to read something from a table. Which table? You mention as from this table. Now what is meant by this star? Now every table, you can say that has a bunch of rows and a bunch of columns. Can I say that? So this star tells that I want to fetch all the columns of every record. Star means every column of a record. Here star means fetch all the columns of a record. If you want specific set of columns only to come up, let's say there are 10 columns and you only want the 3 columns to come up, then you can actually give the name of the columns. Instead of giving star, you can say col1, col2, col3, right? You can give it like this. So it will just select these 3 columns, but like it will get all the rows, but for every row, it will just get these 3 columns. But if you want all the columns, you say select star. This star means all columns. Okay. So let's do one thing. So let's execute this, I would say statement. So I'll select it, run the code, and can you see we are able to get the record of all of the actors. You can see 1, 2, 3, multiple actor records are coming up. And you can see in the actor table, there is a column actor ID. There is a column first name, last name, address ID, last update, right? Now let's say you don't want last name, address ID, and last update. You just want actor ID and first name. So what you can do is, if you want specific columns from a table, so instead of star, write commas separated column names. Okay. So you can do something like select actor ID, comma, first name, and then you say from which table. So from is a keyword, so you say from and then the table name, you say actor. Okay. And now if I select it and execute it, can you see now only actor ID and first name is coming up. That's the beauty. So you can select if you want some specific columns to come up, or you can do all the columns I want, right? Anything like that you can do, right? In fact, you can actually give aliases to a column. For example, you don't want this to say actor ID and first name. Instead, let's say, so while printing, we can give alias slash nickname to a column, right? It will not permanently change the name of the column. It will be like a nickname that you are giving to the column. So how can you do that? Using as keyword, okay? Using the as keyword. How do you do it? So I'll copy the command from here, paste it here, and you can say select actor ID as ID and first name as name, right? And then let's say if you execute it, can you see instead of actor ID, now it is saying ID, and instead of first name, it is saying name. It has not actually changed anything from the table. This is just like for temporary. While printing just this, we have temporarily given them a nickname. So if you select, like, execute query on line number 12 again, you can see the column name has not changed. The column name has not changed. It's just that for this particular query, you have actually given kind of like alias to it. But now a question must be coming to your mind that how do we know what all columns are there in a table? Do we need to print it always? No. You can fetch details of a table using DESC command. So DESC means describe. So you can say DESC actor. And now if you run it, you'll get the details of all the fields, or field is the column. That there is actor ID column, first name column, last name column, address ID. They have some types, small int, varchar. Don't worry, I'll tell you about varchar. Timestamp. Are they ever going to be null? No. So you can actually use the describe actor, I would say command, or I would say describe table name. Describe, and then you can write table name command to actually get the details of a particular table, that whether that particular column possesses some specific property or not. For example, this actor ID is a primary key. It's a special property. I'll tell you about primary key, but it's a special property. So you can get all of that detail directly here. So now let's go here. Oh, my bad again. Now let's say we'll say use LCO films. Okay, in every file, every new file, you have to write use LCO films, right? Okay, and let's say if I do select the keywords, generally I prefer to write in caps. Otherwise, again, as I said, it's a case insensitive, so nothing matters as such. From actor, okay, executed. Cool. Now let's say these are the details of the actor, but we have more tables, right? We have more tables, okay? So let's say there is a table called as film. There is a table called as film. Let's see what's inside film. So you can see a film has a film ID, title, description, release year, language ID, rental duration. A lot of things are there. A lot of things are there, okay? Now let's try to have some more queries. So let's say I want to filter something, okay? If you want to filter data, you can use the where clause. Okay, so let's say I want to filter out the data. I want to filter out all the films who are having a release year greater than or equal to 2018. That the release should have, the film should have released on the year 2018 or beyond, or I would say after that, nothing before. So how can you do that? So you can say something like select star from film, select star from film, and then you can put a where. Where is kind of like putting a filter, that okay, select everything from a film where release year, and then you can put some operators like greater than, less than, greater than, equal to, less than, equal to. These kind of operators you can put, that release year is greater than or equal to 2018. Okay, and now if you execute this file, can you see only those films are coming having release year greater than or equal to 2018. Nothing for 2017, 16 or anything is coming up. If I make it less than, and run it, now you can see nothing after 2018 is coming up. It's all 2018 or less than 2018. If I, instead of less than equal to, I do less than 2018, then it will not even show 2018. It will just show everything less than 2018. So this is how you can actually filter out the data, and you can actually club this command Instead of star, you can just select some particular thing. For example, select title, comma, release year, title, comma, release year from this. If you run the code, now you can see only title and release year are coming where the release year is less than 2018. So this where clause is very powerful with the fact that it can actually help you to filter out the data, right? And this will be required multiple times. You will be required to filter out the data many times, right? And there are a bunch of operators that you can use. We can use a lot of operators, right? You can read more about the operators, but some common ones are less than, greater than, less than, equal to, greater than, equal to, right? There is something like a not equal to as well, and this is also a not equal to, right? There is some like operator. I'll talk about like operator. There's a in operator, etc. There are a lot of operators, right? And you don't need to like by heart learn them. You can just say MySQL operators, and you will find some really good articles or something anywhere. You can see a lot of articles, plus minus, a lot of things actually exist for MySQL, right? So this is how you can actually filter out the data coming from MySQL. Okay. Now, this filter condition, you can make it very complex as well. For example, let's say you want everything. Okay. Let's execute this. So you want everything in the release year less than 2018, but you want that the rental duration should be more than 5, or let's say the rental rate should be more than 3. Okay, more than 3. So you can write some more logical operators as well, or I would say yeah, boolean logical operators. For example, and, or something. So you can say and a and d, and so and here is a and d, and rental rate is greater than 3. Okay, if you run this line, can you see all the rental rates greater than 3 are coming up? Nothing is less than 3 now. So you can actually club complex conditions. This is one condition and this is one condition. Instead of and, you can put a or also, that either the release year should be 2018, less than 2018, or the rental should be greater than 3. Things like these you can actually do. So you can actually club very complex operation as well, and it's not going to bother you a lot, right? And for example, let's say if let's say you want to play with the strings, okay, so you can do select star from film, where you can say title is equals to, if you want to compare a string, you can say Ali forever. When comparing strings, of course, then case and sensitivity will come. It's not like you will write a small case string and it will compare it with a capital string. I guess that is pretty obvious. Only the syntax is case insensitive. So if you select star from film where title is equals to this and run this code, you can see only one film record is coming up where title is this, right? If you make the title something else, let's say a small Ali, I believe this should not work technically, but let's see. Oh, it's still coming. So yeah, I just got like I just remember, you can actually configure this. Probably you can actually configure that string comparison should be case sensitive or insensitive. So you can search for MySQL string comparison case sensitive. Okay, so I guess there is a configuration that you have to enable. You can say binary. Okay, you can say where binary and then the column name is equals to value. So you can say where binary, like this, executed, and now you can see case sensitivity is gone, right? So let me write it here. So by default, string comparison is also case insensitive, like below. Okay, and I'll copy the query like this, paste it here, remove binary. Okay, if we want to enable case sensitive string comparison, only I'm talking about string comparison, okay, then we can use the binary keyword like this. Okay, this is case insensitive, but this is now case sensitive, right? This is something that is pretty cool. I'll actually show you. If I run this, you can see no film is coming, But if I execute the case insensitive one, Ali forever is coming up, right? So this is something that you have to actually always keep in mind. So I'll say um, basic select query for reading. Here we go. We'll add this file as well on the GitHub. And yep, looks good. Now with strings, there are a few more operations. So there is a very interesting operator called as the like operator. So the like operator has one simple task. It can actually help you to do substring matching, prefix matching, and suffix matching. Okay, all these three kind of matchings it can actually help you to do. Okay, so now what we can actually do is, let's say we say use LCO films, and then let's say we do, for the time being, select star from film. Okay, let's execute the code. And let's say I want all the films, which are having, let's say, I want all the films that starts with the word AL. Okay, I want all the films that starts with the word AL. Okay, so let's try to do prefix matching. Okay, how do you do prefix matching? You can say column like, and then you can put a string, and then you can give your prefix string, and what after your prefix string you can put a percent. Okay, something like this. Let me show you. So I want to say title like Ali percent, or AL percent, not Ali percent, AL percent, and we should put a where. So where, okay, where this. So what's happening is, we say that from the films table, select all those records where the title starts with AL, and after AL there can be anything. Percent represents that there can be anything after AL, but it should always start with AL. Okay, if I run this code, can you see all those films are coming which starts from AL? Can I say that every film starts with AL, nothing more, nothing less? Okay, this is something that is very interesting. We did prefix matching. Let's say we want to do suffix matching. Let's say you want to do suffix matching. Okay, in suffix matching, you put the percent first, and after the percent you put your suffix string. For example, let's first of all see what all films are there. Run. So let's say I want the suffix to be like what should I put a suffix? Let's say CK. I want all those films that starts with anything but ends with a CK. Okay, all those films that starts with anything but ends with a CK. Okay, above what was there? All those films that starts with AL and ends with anything. Okay, this is the meaning. So if I run this code, can you see only those movies are coming that ends with a CK, whose title ends with a CK? All these are the movies whose title ends with a CK. This is the power of like operator. Okay, and now what you can do, you can do a substring matching as well. What is a substring matching? In substring matching, you say that it can start with anything, then there will be a substring, and then it can end with anything as well. So let's first of all see what all films we have, and then we'll try to figure out some substring that is common. Okay, so let's say in between there should be a substring. Now substring can be on the start also, end also, and in between also. So there should always be a substring de. There should be a substring de. So I can say where title like %de%. And now let's say if I run this code, can you see these are all the movies which has de somewhere in their title. So this is de devil, then de academy, video de, Amadeus de, identity de. You can see in the name somewhere either on the start or on the end or somewhere in between de comes. So all those film that starts with anything, end with anything, but has de somewhere as a substring. And I believe everyone knows substring. Substring is a contiguous string that you have. So this is a power of like operator, that actually like operator helps you to do any kind of a prefix matching, suffix matching, and in fact substring matching as well. And that makes it one of the most powerful operators altogether which exist in SQL. Okay, so I'll put a file like operator .sql. Okay, I'll upload this file. And here we go. Now let's try to figure out a few more queries. Okay, so now let's say we want to order the data, or you can say sort the data. So let's say you want to sort the data somehow. For example, let's say you say use LCO films and you say select star from, let's say something like film only. Okay, if I execute the code, you can see all the film related data is coming up, but currently this data is presented, or you can say fetched, in the order in which it was inserted. For example, this academy dinosaur was inserted first, so it's coming first, then this is second, this is third, so on and so forth. Let's say I want to sort the data based on release year. I want to make sure that I am getting the data based on increasing order of the release year. That means the movies which have the earliest release year comes first. How can you do that? So to sort the data, we have order by clause, right? You can write order by and mention the columns based on which you want to order the data. Okay, cool. Let's see. So let's say I want to order the data. So let's say I'll say order by. Okay, so you don't need a where here because there is no filtering that we want to do. I just want to order the data. So I'll say order by, let's say release year. Okay, let's see what happens. If I run this code, can you see the data has been now sorted based on increasing order of the release year. So earliest movie 1987. After a bunch of 1987, you can see 1996 coming up. Then after a bunch of 1996, 1999 comes up, right? So this, what this is doing, this is sorting based on increasing order of release year, right? It's sorting based on increasing order of release year. What about if you want to sort it based on decreasing order of the release year, right? So if you want to order like in decreasing order, after your column name you can say DESC. What it will say that select all the records from the film table, order them based on decreasing order of release year, something like this. So if I run this code, can you see now 2020 comes at the top because it's now decreasing order. So the latest year comes at the top. Okay. If you don't mention anything, it's by default increasing order, otherwise decreasing order. If you want to be very specific, then you can also say increasing like this, right? Oh, sorry, ascending, ASC like this. So this is specifically telling that you want ascending order. If you don't write ASC, then also it will do ascending order only. So if I execute this, you can see the output is same as line number 7. So this is explicitly telling ascending order. Okay. This is explicitly telling descending order. Something like this. And this order by is very powerful. This order by is very powerful. Like in normal programming, sometimes what happens is, let's say you have an object. You want a very custom comparison of the object. Like let's say you want to sort the array of objects, and let's say like array of objects like array of films, right? So for example, let's say you want to arrange them based on increasing order of release year. But if the release year is same, then what? Then let's say I want to arrange them in an increasing order of their title. That is lexicographically increasing order of their title. How can I do that? So custom multi-column ordering is also possible. How? We can give comma separated conditions for this. Okay, let me show you how to work with this. So you can say select star from film order by, let's say I want release year in descending order, and then I'll put a comma. And then I'll say title in ascending order. Okay. So now what will happen is, if I run this code, now can you see it's decreasing? That means descending order for release year. But now those movies which have the same release year are now in ascending order of their title. Can you see that? If I remove this title ASC, okay, and run it, you can see the titles are okay. Let's look at some more data. So let's say for 2019, you can see H is coming, right? Then Y is coming, Z is coming. This data has been already inserted also, I guess, in increasing order of their data. So let's see one thing. If I do ascending, let's see, do we have some data there to visualize? You can see T, U, V, and W. Okay, 1996 says. Okay, so this data is already arranged in increasing order of their title already. So let's do one thing. How about rental rate? See the rental rate. Currently what's happening? Rental rate is randomly arranged. 4, then 0, then 2, right? So what I want is, let's say rental rate ascending as well. Okay. Now let's see. Now, if you see this, can you see rental rate has been arranged in ascending order? So you can customize that. Okay. First parameter is going to be this, that first of all, arrange release year in ascending order. If 2 entries are there which have got release year same, then what to do? Use the default ordering or something else. So then this will be coming up. Now let's say if rental rate is also same. For example, here rental rate is also same. Then I want decreasing order of rental duration. So I'll put a comma, rental duration, DESC. Okay, decreasing order of rental duration. So you can see now this value is same 0.9, but rental duration has been in decreasing order. So this is kind of like very crazy thing that you can do. Sorting is very, very easy with this order by clause, right? And in fact, now because you have ordered, you can also filter also. So you can club filtering and sorting. Okay. So what you can actually do is, you'll take, let's say something like this. And before this, so first you filter, then you order. So let's say where release year is greater than 2005, right? So you can see, first of all, what we'll do, we will filter out the data. So first we will filter out all the records which have got release year greater than 2005. And then we are going to order, like sort everything. Whatever is the remaining data, whatever is the filtered out data, we are going to actually sort that. Now you can see everything from 2007 and everything like that coming up. So you can actually club multiple clauses. So where is a clause, order by is a clause. You can club multiple clauses. For clubbing the clause, you don't need and or anything, right? You can see where, and then just after where you put order by. So this, you can say that this is kind of like first operation, filter operation. Once filtering is done, then you order by, kind of like that. So this is like sorting data. Okay. My bad. Here we go. Now, one very interesting, I would say, I guess it's an operator only. We'll check out. Okay. So for example, let's say this was the data. Okay. And let's avoid order by for a moment. Okay. Let's keep order by, but let's keep a very simple order by. So just one parameter. Okay. So currently what's going to happen is if you run this code, you're going to get a lot of details coming up here, right? You can see a lot of rows are actually coming up. Let's say you don't want all the rows. Let's say you want the first 10 rows only. Like at any point of time, you just want 10 rows. So what you can do is you can put something like a limit. So you can say limit 10. Now what's going to happen is if I run the code, can you see I'm just getting 10 records, nothing more than 10, only 10 records. If I say limit 5, I'm now only getting 5 records. So if you want to get limited number of data, you can use limit here. Okay, cool. So in like generally in Google search pages or something, you must have seen that in every page they show, let's say 10 URLs. At that kind of a situation, this is very good that I always want to show, let's say 10 URLs or 5 URLs, something like that. But how do you put that page wala thing? That let's say on the first page, you get the first 5 records. On the second page, you get the second 5 records. On the third page, you get the third 5 records, and so on. How can you do that pagination? So that concept is called as pagination. So if you go to Google and let's say search about, let's say Spring Boot. Okay. So you can see we are getting, okay, so here now they have implemented, sometimes it comes as a pagination, sometimes it comes like this. Let's go to Amazon in that case. Okay, so let's say we go to this book. Okay, or let's not go to book. Let's say let's go to category, all computer peripherals, laptops. Okay, and let's say we will search, we will go for laptops. Okay. Oh, now we'll go, let's say for MSI laptops. Okay, now if you go here, you're on the current page, bunch of laptops are coming. And can you see it asks you to go to the next page? So most probably I guess 40 odd laptops are coming on this page. And then it asks you to go to the second page. On the second page, next 40 laptops will be coming up if there are 40 laptops. Otherwise, let's say if there are less than 40, then all the remaining ones will come up. This kind of a situation, this pagination kind of stuff, how can you build that? So one thing that we learned that we can very easily do operators like limit that I just want 5 records. Apart from this, what you can do is there is an operator called as offset. Offset means that from which record you want to start getting the result. So let's say if I say that from the 0th record, okay, from the 0th record, I want to get the data. Now you can see there is an error coming up. Let's see what's the error. Okay, so there is some end of file exception. Let's do it one second. No, somewhere else. Okay, let's write offset after offset 0. Yeah, okay, after limit you have to write offset. So now if I execute it, currently we are getting Pluto, Oleander, Platoon, Instinct and everything. If I run this, you can see same result I'm getting. That means from the 0th record, we are getting 5 records. Now let's say if I make the offset as 1, instead of Oleander, you will realize the first record is now Instinct, right? So you can use this offset to actually control that which record you want to start with. So I want to start with the 0th record and get the first 5 records. So 0, 1, 2, 3, 4. Those 5 records we are going to get. If I want to get the next 5 records, so that next 5 record means nothing should be repeated. So I'll put a 5 here. Now you can see from the 5th record everything is coming up. Okay. And let's do one thing. Let's keep a track on the movie ID to understand, otherwise I'm forgetting. You can see there is nothing like 681, right? See, nothing like 681 ID is there. The moment you do it 5, you get 681. That means from the 5th index you are getting the next 5 records, that is 5, 6, 7, 8, 9 up till the 9th index. Then let's say you put the offset as 10. So what will happen, from the 10th index you will get the next 5 records and so on. So this is what the use of offset is. Using this you can actually put pagination in place. Like if you want to have a paginated API or something, this limit and offset together can be a very powerful tool. You can get the records, however number of records you want, that is the number of data per page will be limit, right? Per page I want 5 data, per page I want 20 data. So let's say if you want 20 records per page. So if you start with 0, then you can get first 20 records. These are the first 20 records. You can see last is 668. Now let's say you go to 20. So that means you're going to get the next 20 records. So offset 20, limit 20 means page number 2. Offset 40, limit 20 means page number 3, and so on, right? So this is a pretty powerful tool. You can actually try to understand, right? So if like you can say, like if your page size is X, right, then page number will be number into, I would say, or we should say it like, then odd offset should be, right, whatever is the page number that you want, page number into X. Okay, 0th based indexing. So if you want the 0th page, you can say 0 into X. If you want the first page, in the offset you will put 1 into X. If you want the second page, in the offset you will put 2 into X, and so on. So this is the formula you can apply. So for example, let's say if the page size is, let's say, 10, so then what will happen is 0th page will be 0 into 10, that is offset 0. Okay, then first page will be 1 into 10, that is offset 10. 1 into 10 is 10. Okay, then second page 2 into 10, that is offset 20, and so on. So this is something that you can actually use in order to prepare a kind of like a paginated API kind of a stuff for you. Okay, so I'll put as 7. Now let's say if you want to update some data, how can you update some data? Okay, so I'll get some data from here. Okay, if I run this code, let's say the release year of Paris Weekend, the film with ID 65 with the title Paris Weekend, I want to update. How can you do that? Right, so update can be done using the update command. Right, so there is a dedicated update command that you have, and using which you can actually update the table. How the update command works, you can say update table name, and then you can say set whatever column you want to update. Column to update 1 is equals to value 1, comma, column to update 2 equals to value 2. So whatever set of columns you want to update, you can put that. And then if you just put this, then what will happen is it will update all the records of the table. It will go to all the records of the table and set the values of the given columns to the given value. But if you want to update a specific record or a set of specific records, then you have to filter those records. So you can say where column is equals to some value, something like this. So let's try. So if I say update, you can say film set release year is equals to 2008, where film ID is equals to 658. Okay, something like this. So currently release year of film ID with 658 is 2007. I'm setting it as 2008. If I run the code, you can see nothing came up because update query doesn't return you anything. But now what you can do is you can say select star from film where film ID is equals to 658. And if I run the code, can you see now the release year of the film with ID 658 has been updated to 2008. So this is a very powerful way to actually update your records inside SQL, right? So I'll say it updates in SQL. So we know about how to update, how to read. Now let's talk about deletion. So if we want to delete data, you can say delete from, and then you can put a table name, let's say film, where film ID is equals to 658. Okay, I guess we were updating 658, right? Yeah, film ID is 658. Okay, film ID is 658. Okay, cool. And then let's say we can try to do select star from film where film ID is greater than 650 and film ID is less than 660, order by film ID. Okay, so let's try to execute this query before delete and after delete. So before delete, I want to get all the films with film ID 650, greater than 650 and less than 660, and we are going to order them by film ID as well. So if I run this code, can you see what we are getting? We are getting 651, 652, 653, 54, 55, 56, 57, 58, 59. Now let's say I will delete a film. So okay, let's see what happened. So you can see if your query executed or not, you can actually read it in this action output. So you can see some error actually came up. Let's try to read the error. Oh, okay, got it. So sometimes what happens is the record that you want to delete is getting used somewhere else as well. Okay, so if that is the case, then you have to be careful, and SQL cannot directly allow you to do that. So let's actually see. So okay, film actor it is actually using. Okay, let's try to delete something else in that case. I guess address might be already getting used. If I use actor columns are actor ID, this is address ID, right? Yep. Do we have a table that is not dependent on anything else? Film category, film ID, category ID. I guess film category is not dependent on it. Like no other column, no other table depends on film category. Let's try to do it for film category. Okay. So let's first of all get film category. So film underscore category. Okay. Let's see what all film categories do we have. Run it. These are the film categories, right? Okay, cool. So let's say these are the film categories, and we say where film ID equals to 1, order by film ID. Okay, let's try to execute this. So all the, okay, so this is only one. Let's say film ID 2. Oh man, this is only one. What can be the common property that I can keep? Yeah, category ID I can keep instead. Category ID is equals to, let's say, 11 and order by category ID. Let's get this. Cool. So there are a lot of records with category ID 11. Okay, cool. And I'll try to get this as well. Cool. Now what I'll do is I'll delete from film category where category ID is equals to 11 and film ID equals to 2. Okay, you can see this is what I'm going to delete. Let's try to delete it. You can see now it comes with a green tick, that means delete successfully happened. Now let's see what all details do we have. And can you see the first record with 11 comma 2, the film ID to 11 category is now gone, which was coming up here. So this is how you can actually delete something inside your SQL file. So deletion in SQL, right? This is how you can actually delete a record from a table inside SQL.